My name is Thomas Dimitrovich. We are going to continue our discussion today around service equipment. So it seems like a broken record, but we've been talking about service equipment and all of the items that were related to that for the last, goodness gracious, I don't know, maybe 4 weeks, 4 sessions together. I don't know if this is the third or fourth. But we talked about services. We talked about connecting generators to those services. And now we're going to get into interconnected systems, which means we're going to move into when we connect not a generator, but rather a photovoltaic, wind, energy storage systems. We're going to talk interconnected systems. Get out your code book. We're going to be focusing on the 2023 code. So get out your code book, grab your NFPA link, get a cup of coffee. Let's talk interconnected systems, and it all starts now. Felix, welcome, buddy. Hope everything is doing well for you, my friend. Glad to see you on the call earlier this morning as well. So we're going to talk interconnected systems. I'll tell you what, Felix, this is a topic. I think many think it's confusing, and I don't know. As I break down the systems, I'm starting to feel a lot more comfortable in and around working with the interconnection of systems. We are going to talk about the connection. Hey, good morning, Mr. Wages and Joseph Violi. We're going to talk about that connection point. I'm going to focus in first on the line side connection. I don't think I even developed the slides, but here's what I'm doing. I'm going to show some PowerPoint slides, and I'm going to look for the chat. David Engelhardt in the house. I'm looking for the chat to see the images that I'm having and the slide deck. And as I build this out, I just want, you're my guinea pigs, right? So you're going to help me put together a rock solid slide deck for the IAEI. All right. So let's talk interconnected systems. I'm going to put this in presentation mode. I'm probably going to lose some people here. There we go. So if I do that, if I do this, and then I do that, there we go. Laurel in Omaha. Thank you for joining in. And Larry Griffith. Sorry, Larry. Good afternoon. All right. So interconnected systems. I've got a diagram here where I'm showing the photovoltaics, and you're probably gonna yell at me for this, but I'm showing 3 what I think are very people will recognize those as batteries. Okay. Typical energy storage systems will probably come in a different format. These, I just wanted to represent batteries. So I'm going to call those an energy storage system. And then I have a panel board, which I'm showing as a service entrance panel board. Now, on a call this morning and a little bit later, on a phone call with Robert from Omaha, Mr. Weber, he gave me some really interesting insight, and he made a statement this morning that what he does is he looks at these systems. Hey, Robert from Omaha. Excellent. I'm talking about you. You made a very good point this morning that the systems, when I think about that, is an Article 690 system. I should be reviewing the photovoltaic installation in regard with an eye on 690 to make sure that I am installing that system correctly. And Article 690 governs photovoltaic systems. When I think about an energy storage system, it's Article 706 that is my driving factor. Now, I will say that in addition to Article 706, what I've drawn are these lead acid batteries. But that's a 480 stationary standby. So you got to be careful when you get to reviewing all your different systems, right? And I don't show a windmill here, but I would say you need to look at the article for wind generation. So each of these should be treated separately in addition to, whoops, almost stopped streaming. In addition to services, right? So we've got to look at services in Article 230. And I would argue that since that's a panel board in the picture that I'm drawing, Article 408 would apply, whether it's a panel board, switchboard, or switch gear, your service equipment. You have Article 230, but then you can't forget the fact that there are other items within each of these, whether it be an energy storage system, an Article 690 system. Every one of these are going to have overcurrent protective devices, conductors, and in the case especially of a panel board, you have circuit breakers or fusible switches, you have surge, and all these other different, there are other articles that pertain to all of this. But what I'm trying to do is just talk about the interconnection, and you got to think about the grounding and bonding for everything, right? So Article 250 applies across the board. So, but what I'm trying to focus on here, and what my original intent of this slide was, that we have an AC system and we have these DC sources. Somehow we've got to marry the two together. So I think Robert's point was very valid, that we should treat all of these DC types of systems as a focus from a design and inspection perspective, and then you have to understand how they all interconnect. So 690, 706, Article 230, Article 408, Article 250, and then we're going to bring them all together in 705. Makes sense? And I'm, again, I'm oversimplifying. But that's sort of where my head's at in this regard. Okay, so I'm going to move to, now, when we bring these things together, we have to have some piece of equipment that's going to bring the PV system, that's going to bring the energy storage system and do the management of those. And we typically get that done in an inverter. Okay, the inverters are pretty sophisticated pieces of equipment these days, and Yummy Fudge, glad to see you here. And that inverter is doing the job of charging the energy storage system, and then bringing the power in from the PV. In this case here, if I connected this to the system, that could be my PV disconnect. It could be. I could have multiple inverters, right? And I'm not showing multiple inverters all going into recombiner boxes and things of that nature. I'm simply showing one converter, and I'm not showing the complexity on the PV side. I mean, there's a lot to be said about how simple or how complicated photovoltaic and wind and energy storage systems can get. I am simplifying to get to the fundamental rules so that we understand. Once you understand the fundamentals, in my opinion, you just apply those fundamentals on a broad scale, because the fundamentals shouldn't change. Grounding and bonding is grounding and bonding. Once you understand grounding and bonding, I can apply it to any of the equipment that's in all of these systems. I could point it to you, I could tell you about it, but I understand the fundamental principle here, and once I understand that, then I apply it to all of my systems. So that's sort of where I'm going. All right, you with me, Engelhardt? All right, so let's talk about connecting on the line side of the service. Disconnecting means. So here's the way I drew this. Now, you might say, boy, those bends on that raceway is pretty tight, Tom. But again, remember, I'm not to scale. It's just a picture. So please be kind. And I'm trying to get a lot on this screen. Now, what I am showing here, and let's take a look at the focus on the service equipment. I have the line side barriers. The line side barriers are required by 230.62 because it's service equipment, enclosed or guarded. You have to put barriers in place on service equipment such as no uninsulated, ungrounded service bus bar, etc. is exposed. So that's that requirement. Let's start up here. These are service conductors. Those are service entrance conductors. Service entrance conductors are the service conductors. So they're all service conductors. And there's a defined term for service conductors. I go through all of those items. So service entrance conductors are service conductors that go between the terminals of the service equipment, which is service equipment, to the service drop, overhead service conductors, service lateral, or underground service conductors. And I'm going to show you those in a minute in a different diagram. But it's important to understand the definition of service entrance conductors, because when we get to those power distribution blocks and the section that governs it, you'll know where you can put those and where you can't. All right, so those service conductors. Now let's talk about these power distribution blocks. These are in 230.46. These are service entrance conductors. So that means you can't splice and tap a service drop. You can't splice and tap a service lateral. You can't splice and tap overhead service conductors. But you are permitted in 230.46 to splice and tap service entrance conductors. So it's very important to understand the distinction and the definitions of what all of those conductors are, and we're going to review those. Power distribution blocks, pressure connectors, and devices for splices and taps, they shall be listed. And the power distribution blocks and the connectors and those devices for splice and taps shall be marked suitable for use on the line side of the service equipment or equivalent. Now, Robert says distribution blocks rated for fault current. So they need to be rated for fault current. So you think about these conductors as they come down through the system, they land on an overcurrent device. The downstream overcurrent device gives you your overload protection, but there's no short circuit protection for these conductors and those components. But what we do to limit the possibility of damaging those conductors is we put them in raceway. We protect them physically. That's our goal, is physical protection. So Article 230 has requirements for physical protection. Yummy Fudge, I was just reading your comment as a random aside. And you know what? That's like, it's squirrel. You just yelled squirrel. As a random aside, that really is kind of off topic, but my installation has no service entrance conductors. So I'm saying, I'm not sure what you mean by that. Straight from the source to a breaker via a non-accessible bus bar. So let's look at the definition. Let's go back. Power distribution blocks. Let's take a look at the definition. The service conductors between the terminals of the service equipment to the service drop, overhead, or underground. So you do have service entrance conductors, Yummy Fudge, because you have It says straight from the source to a breaker via a non-accessible bus bar. Your service entrance conductor is that bus bar then. That would be your service entrance conductor. Remember, a conductor doesn't have to just be a wire, at least in my opinion. We'd have to look and see if there's a Michael Hofkin. Michael Hofkin, let me ask you, can a bus bar be a conductor? There we go. We have the man, the legend, the famous individual, Michael Hofkin online. Michael, what are your thoughts, buddy? Laurel, 230.46 was in 2020, but deleted in 2023. 230.46 was deleted in 2023. No, it is there, Laurel. It is there. Where is it? 230. A bus bar can be a conductor for sure. You are the man. I knew I could count on Michael Hofkin, the Hofmeister J. So 230.46 is in the 2023 code. Double check that, Laurel, just to make sure. I'm looking at the code right now. There it is, 230.46. She is there. All right. Great. No problems, Laurel. No problems. Happy to be wrong if I learned something. Amen, Yummy Fudge. And that's the same here, brother. So don't take any of these diagrams as gospel. Please point out any issues. And let me know if there's a different way you connect into service equipment. I just showed power distribution blocks. I didn't show, there's Polaris configurations. There's split lugs and bolts and all that good stuff. I'm showing one conductor coming in and two going out. One going to one set of service conductors going to the panel board and one set of service conductors going to this inverter. All right, so we talked about the power distribution blocks. We talked about the service conductors. Let's talk about this neutral. 250.24D grounded conductors. In this area, we require the grounded conductor to be pulled to the routed with the ungrounded conductors to each service disconnecting means and shall be connected to each disconnecting means grounded conductors terminal or bus. Now, I don't like that language. We know what it means because I like the fact that they said grounded conductors terminal or bus and not the disconnecting means, but it's the equipment. It should say, in my opinion, it should say that the grounded conductor shall be routed with ungrounded conductors to each service equipment, because the definition of service equipment includes the disconnecting means. And then it should be connected to the grounded conductor terminal or bus in the service equipment. I might put a public comment in there, I don't know, but that's what it should say, because the service disconnecting means is in service equipment. All right, so that's my grounded conductor that's required. Now these conductors are service entrance conductors because, now let's look at what it says. The service conductors between the terminals of service equipment. This is service equipment. It's the necessary equipment consisting of a circuit breaker or switches and fuses and their accessories connected to the serving utility and intended to constitute the main control and disconnect of the serving utility. This is service equipment as well. It's connected to service conductors. It disconnects the serving utility from the system. The several definitions of conductor do not mention wire. A conductor is that which conducts or transmits heat, electricity, or sound in the Oxford Dictionary. Thank you, Michael Hofkin. All right, connected to the Robert, connected to the terminal bar or bus, so it will not be connected to enclosure. Well, we do right. So, but we do the bonding, right? There has to be a bonding jumper in, and we'll talk about that. So that is service equipment. Let's talk about this bonding. I think I have this. So the main bonding jumper is the connection between the grounded circuit conductors. So that's this grounded bar, and the equipment the grounded circuit conductor. That's this bar here. where the neutral or grounded conductor is connected. The grounded circuit conductor and the equipment grounding conductor. So that's this. The equipment grounding conductor is this this bar over here. And in many service entrance panel boards, we will have that. And we talked about this in one of the first sessions of Article 230. Those two will be bonded. Now we will typically, if that bonding strap is not there, because I can't use the back pan as my connection, I could elect, if that bonding strap is there, then I could land this grounded conductor either on that neutral or on the equipment grounding bar, either one, as long as there's a main bonding jumper in that's a physical bonding jumper, and I'm not using the back pan. But we always land it on this neutral bar, this grounded bar, which is insulated from the panel, but then bonded through the main bonding jumper. 250.24C says, for a grounded system, an unspliced main bonding jumper shall be used to connect the equipment grounding conductor and the service disconnecting enclosure to the grounded conductor within the enclosure for each service disconnect in accordance with 250.28. And 250.28 is going to tell you what is permitted and what's not permitted. Okay, so that's that portion of the system. Now that all has to be done, and I don't show my ground rod. Somehow I lost my ground rod. It's in here somewhere. It's in a different picture. I think in copying and bringing this over, I forgot my ground rod. But I have to have my ground rod, my grounding electrode conductor, connected to my grounding electrode for both this service panel board and the inverter. So I'm going to have to add that. I need a pen. And I need a piece of paper. I am going to, there we go. I got a notepad. All right. Whoa. I got to take a note. One, missing grounding electrode conductor and grounding electrode. All right. Yes, bonding jumper to the enclosure, Michael Hofkin. All right. So we covered this. This is a service disconnecting means, right? So that disconnect in this inverter, because it is disconnecting you from the service conductors, it is a service disconnecting means. And that definition right there is new for the 2026 code cycle, which is a critical piece. So we now have a defined term, or we will have a defined term if it passes and through the second draft. Panel 10 did a lot of work for this defined term, and we made a lot of other changes in Article 230 to accommodate it. So that's a service disconnecting means. Yummy fudge. So I'll tell you what I do. I typically use my notepad for my notes electronically for a few different reasons. I can search them. So, but right now, during this right here, I don't have any room to open up another app, so I got my notepad. All right. Yes, Robert, in this case, the inverter has to be rated as service equipment. So it has to be listed it can be suitable for use as service equipment or suitable only for use as service equipment. Either way, that is where you're going to do your bonding, and you're going to bring your grounding electrode conductor to this equipment. You're going to have your bonding of your neutral and your ground bar, just like you do on the service panel board. You're going to have line side barriers on the service disconnecting means, because that's a service disconnect. You'll have to have the line side barriers. You're also going to have surge, right? So an SPD is going to be needed. So you need a surge protective device. This can be a type 1 or a type 2 because a type 1 is permitted to be connected on the load side of the service disconnecting means or on the line side. But typically you'll see a type 2 in this location. So that's required as well. So the important thing is, once you call it service equipment, there are a lot of other requirements you need to follow. You have to make sure that it doesn't count as one of the 6, which it doesn't. I believe we have We have permissions in Article 230 that the that the photovoltaic does not count as one of the required 6 disconnects. What else? I think that covers a lot of. I think that covers a lot of what's here. Okay. I gotta get rid of all those. Got the main bonding jumper. We talked about all those. So now, now what I'm going to do is I'm going to change it up a little bit. I thought I was going to change it up again. There we go. So those are the conductors. This is everything we just talked about. So there's just 2 different ways to do these slides. That wireway it has service conductors. Those are service entrance conductors. So in the previous discussion, this was the diagram I was thinking of. So we have Yummy Fudge. That's Article 230, six devices. I'll give you that reference in a second here, in a little bit. Let me walk through this. So here are your defined terms. There's your service drop, the overhead conductors between the serving utility and the service point. This is your service point. The point of connection between the facilities of the serving utility and the premises wiring. This is your service lateral. The lateral is the point of connection between the facilities of serving utility and the premises wiring. These are your overhead service conductors. None of these locations can you tap into for PV or any alternative energy solution. The overhead service conductors. The overhead conductors between the service point and the first point of connection to the service entrance conductors at the building or other structure. And then, those are your overhead service conductors. These are your service entrance conductors. Service conductors between the terminal of the service equipment to the service drop, overhead service conductors, service lateral, or underground service conductors. So that's what the service, and that's a very important term to remember and a very important part of the power distribution system for you to recognize, because that's where you're going to be tapping in for your alternative energy equipments. Thank you, David. I don't know what just happened. I didn't touch anything. There we go. Thank you, David. 230.71 is the reference. You're the man. See? Teamwork. And then you have your underground service conductors. Steve Froming says, but people do tap in for grow lights. I don't know how, Steve. What is the permission? You have, how do they do that? I don't know where in the code that would permit you to do that. Now, they may be doing it, but I think you would need to have some code language that would permit you to do that. But then again, there's no prohibition either. It doesn't say you shall not. That is a good question. So tapping in to any service conductor other than service entrance, SE. They do it to bypass the meter. All right, illegally. Thank you very much. I was a pot. Steve Froming says, okay, I don't know what you mean by pot when you're talking grow lights. Just anyway, we're going to move on. So here's just another diagram, another great IAEI diagram. You have your service point. You have your service drop. There's your service drop, the overhead conductors between the serving utility and the service point. And these are your service entrance conductors in Raceway. A service entrance conductor is the service conductors between the terminals of the service equipment to the service drop, blah, 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 blah. So very important to understand terminology and to be able to identify all the pieces of pie. Yummy fudge. All right. These are just other examples. So I'm building out. So what I'm doing is I'm grabbing some of our beautiful slides from our other portions of the IAEI slide deck to try to build this into a service entrance discussion. These are your definitions, defined terms. You got service conductors, overhead. We talked about all of these: underground, service laterals, service drops underground, etc. So we've got all of those covered. There's your 230/46. We already talked about that. We already talked about the service conductors. Those are all service conductors. There's no difference between the conductors serving the panel board from that terminal block to the conductors serving the inverter, the IAEI inverter. Big misconception I've seen is a lot of people may not want to call those service conductors that go to that inverter. Sure thing, Laurel. They may not call those service conductors because they're, in my opinion, and I think based upon the code language and other people's opinions, the argument I've heard is that the PV system is putting power in, so it's acting like a utility, but it's not owned by the utility. It's a power source. But the challenge with these conductors is not under normal conditions, but it's under faulted conditions. So if there's a fault in that inverter, there's no overcurrent device to provide short circuit protection ahead of that inverter. So we take precautions. In 230, once you call these service conductors, then you pull in Article 230 and all of the provisions of 230 because they are service conductors, service entrance conductors. You have to follow the rules in Article 230 to physically protect those conductors and follow all the different rules for bonding, all that good stuff. All right. That is service equipment. We already talked about that. That's a service disconnecting means. We already talked about both of those are service disconnecting means. We have the line side barriers as part of 230/62. Surge protection is required in service equipment, so that's a requirement as per 230/67. And then you have the 250.24 grounding that you need to have. You need to route your grounded conductor to that equipment. Okay, so they can pull from or push to the serving utility as well. That's you're absolutely right. And the pull from the utility would be under faulted conditions, right? Yummy fudge. That's the big challenge in these systems, and a lot of people lose sight of the fact that we have to protect for normal and abnormal conditions. So now what I did, take a look at this image. So now what I'm doing is now I got the grounding electrode in there and grounding electrode conductor. Hey, just a quiz question. Can I put two conductors down here? Can I put two conductors underneath that connection to the grounding electrode conductor? Robert Nelson in the house. How would adding a few solar panels affect the service coming off of the pole? My thoughts on that, Robert, you're probably going to pull less current when you are providing power from the inverter. You may have restrictions because you may be putting power up to the pole, but make sure you talk to your utility because some utilities don't permit that. They need to know about that. I'm not sure. Hopefully, I don't know, Robert, if I'm answering your question correctly, but those are my thoughts. The immediate thoughts that popped to my head. Putting a few panels on a structure, connecting through an inverter. You have your disconnect. You're connecting to the line side. Hopefully, that energy is being used by the dwelling unit or whatever the structure is. And if you're producing excess energy, it could flow back up to the utility. But again, you got to be careful. I know some utilities prohibit that and would fine you for doing that. So just be careful of that. Andrew Casney, voltage rise concerns. Could be, yes. Only if rated for 2 conductors. No. So Robert Osborne says, only if that is rated for 2 conductors can you put 2 wires under the same lug. So I need to check that image to see if I can do that. 2 grounding electrode conductors under the same, what would you call that connector? I don't know what you call that for ground rod, for the grounding electrode. All right. But I drew that, and I drew it last minute. So dual lug rated equipment. Kevin, thanks for chiming in, Kevin. So the important thing would be for that connection point for that grounding electrode conductor, I'm going to have to pull some of the information literature of those who make those connectors to see if a ground clamp can take 2, or how would you connect 2 to that ground rod. Okay, so in this case here, now the inverter is not service equipment. I still put and the only reason I put the raceway, the conduit in there like that, the metal raceway, I put that metal raceway in because I already had the image drawn and it was easy. So, but it doesn't necessarily have to be in a raceway, right? What else do I have in there? So I have my line side barriers. So I've got both of those are service disconnects. That's where I'll have to do my grounding and bonding. You'll notice I have surge on the service disconnect on that disconnect switch. Oh, Robert's right. So that's another good point, that the inverter would have, if I lose the utility, then the inverter, if it's a utility interactive inverter, if it is a utility interactive inverter, it shuts off when the utility goes away. Steve Froming, aren't grow lights covered in Article 512 by, yes, May 12th. So 512. So I have the service disconnect. My grounding and bonding is going to occur because it's service disconnect. I have barriers in place. You have the barriers up there. You have the surge protective device in there. You have your grounding, and you have your bonding. Your main bonding jumper has to be in there. You bring your grounding electrode conductor in there. I have to bring my grounded conductor from my utility in there and land it per the code, per the previous codes. So all of the requirements for service equipment will apply to that disconnect switch. And I might have multiple sources. So there's a whole nother IAEI program on grounding and bonding that talks about all the details with grounding and bonding. So maybe what I'll do, Robert, is I'll grab one of the images out of that slide deck to just speak to that, those terminations. Robert Nelson, in which step of the process does the power company give up control to the residential wireman? Does it stop at the inverter? It stops at the service point, Robert Nelson. Your service point is your line of demarcation where the NEC takes over. And it's not that they give up control. The control, I guess, the thing you've got to remember is this equipment will be listed, like the inverter is listed to UL 1741, which is designed and built in combination with other IEEE standards and with the eye on the utility for utility interactive and all this other good things. So the product standards. So you'll see a lot of utility engagement in the product standards, so that when an inverter is made, it's made with an eye on the utility. And then from an installation perspective, utilities are all over Article 230. I mean, that's service equipment. And they should be all over Article 705 as well. In fact, I think the stimulus for Article 705 came from an IEEE document that was heavily driven by the utility industry. Yeah, and the meter. So yeah, and then that meter, your service point may be the meter, right, Andrew? Um, that may be the service point, and then that's why the utility will tell you they don't want the grounding and bonding done in that meter. It's ahead of the service disconnecting means. But those conductors that come from that meter down are typically under the purview of the National Electrical Code. The utility does not own the panel board, right? So, and I'm not showing the meter in this case. So, but that service point is your line of demarcation. Electric Tech, Wood County, West by God, Virginia. Electric Tech class of 2025, Wood County, West Virginia, tuning in. Excellent. Thanks for tuning in. I'm up here in Weirton, West by God, Virginia. So thanks for tuning in. All right. So, all right, Andrew. Great. Thank you, sir. All right. So let's continue on. There's our 23062 barriers. Those are required. And that's the real important part about calling these service disconnecting means. The moment you call something a service disconnect, you bring in the requirements of services, and the barriers is one of those important items. Happy Tech Tuesday. CT meter is owned by the utility. Very good. Thank you for bringing that in. Yes, so the moment you call something a line-side barrier, you're pulling in, or I'm sorry, the moment you call something a service disconnecting means or service equipment, you bring in the requirements of Article 230. Okay, so now let's talk about, now let's get into, so we've identified the different parts and pieces. Let's talk about 705, and I just started putting this in. 705 has the requirements. Now, 705.28. Now, even if I'm, so, and I don't have a slide for it yet, but I could connect this to, like, see how that surge protective device in the main panel board is connected to a circuit breaker. I could connect that inverter to a circuit breaker inside of the main panel board. That would be on the load side of the service disconnecting means that gets you into 705.12. Everything I'm talking about here is 705.11. Connecting into the line side of the service disconnecting means. If you're coming into the load side, now you're into 705.12. But let's talk about circuit sizing. And if you look at 705.28, 705 is not a very large article. It has some important information in there, but it's not a, your IAEI inverter, look for a distributor near you, Willie. So just saying. 705.28 says you've got to determine what the current is. So here's the challenge when, okay, reset. When I'm dealing with regular equipment, forget about inverters and all that jazz. When I want to determine the amount of current or the maximum amount of current flowing through a conductor, what do? I go to Article 220, or now it's going to be 120 for the load calculations, right? I go to my load calculations, I calculate, and then we speak in the terms of loads. When you are dealing with inverters and you're dealing with photovoltaics, wind, energy storage systems, those aren't loads, those are power sources. So if I think about the load on a conductor, when I think about the amount of current passing through a conductor, I can't think about that in regard to what I normally think about, which is loads. I have to focus my calculation. I have to focus my energy around power sources. So when I'm thinking of these conductors that are coming from an inverter, they're not loads. I'm not calculating a load current. I'm calculating the amount of current that inverter can put out. That's how I'm going to size those conductors. So for that reason, we don't go back to Article 215 for sizing those conductors. And if in the case of when my inverter was my service equipment, I don't go to Article 230 to calculate my loads on that conductor, because Article 230 is going to talk about load currents. We need to talk about source currents. So what 705.28 says in A, power source output, because that's a power source and it's an output, I size these conductors, not for short circuits, I size these conductors for how much energy or how much current that inverter can put out. So what you get in 705.28a is guidance on how to calculate that. And what it says is that your power sources shall be calculated by the sum of you have to use one of these three. It's either the sum of the continuous output current ratings of the power production equipment, because I could have multiple inverters. Two, for power production equipment controlled by an energy management system, I use the setting of an energy management system, and that is a 750 article. And in the 2026 code cycle, it's going to be a 130, Article 130 coverage, because that's going to be your energy management systems. And then the third option is where the sources controlled by the energy management system are combined with the other sources on the same power source output circuit. The sum of A1 and A2 is used. So A1 is the sum of continuous output current ratings of the power production equipment at the circuit nominal system voltage. Item 2, I use the setting of the EMS. And when in item 3 tells us when I have sources that are controlled by EMS are combined with other sources, then I add the two options above. I'm sure it's as clear as mud. Let me look, see if I have any. Current is produced from PV, yes. Everybody saying hi. Hello, Mr. Electric. Jimmy Tyler, welcome to the stream. But the inverter is still the control device. Does that not make it part of the service equipment? Again, no. In this case here, it is a feeder. So that's not service equipment, because that disconnect is not disconnecting service conductors. The service conductors stop at that AC disconnect switch in this image. All right. I was going to say, so I have to calculate the maximum current that is capable of being delivered to the infrastructure, right, through those conductors, and that's in 705.28a. In 705.28b, I calculate my conductor ampacity, and what this does is it takes my maximum current, and I do the same thing we do in branch circuits and feeders. We do two calculations. We calculate the maximum current. We do the 125% for the continuous loads without adjustment correction factors. So if I have multiple conductors, if I have temperature correction factors, all that jazz. I forget about all of those. I do the 125% times that maximum current, and I get that size conductor. Then I do another calculation. I apply all of the adjustment and correction factors, and I don't apply the 125%, and I get that number. And then I make sure that my conductor size is the larger of the two. Now, I do have also in that same section where connected to feeders, if smaller than the feeder conductors, the ampacity as calculated in 240.21b based on the overcurrent device protecting the feeder. So the challenge, I think, and where people may go off the rails a little bit is the fact that we're familiar with how we do Article 215 and 225 and 210, right? We do the same calculation, but we base it on load currents. All you're doing here is the same calculation, and you're basing it upon this output current from the inverter or what we just calculated in A. All right, so don't let it get you wrapped around the axle. I think it's relatively simple. We just can't use the exact same language we have in 210 and 215 for the main reason that it's not a load that you're sizing the conductor for, it's a source current. I mean, that's all the difference is. And then there's in 705.28c, we have the guidance and the requirements for calculating the size of the neutral conductor, the single phase line to neutral power sources, and then we have neutral conductors used solely for instrumentation, voltage detection, or phase detection. So those are we call them neutral conductors. They're grounded conductors. And you're sizing those by either one, when you have a single phase line to neutral power source, and then in 2, when you have a neutral conductor used solely for instrumentation, voltage detection, or phase detection. So they're giving you guidance on how to size those neutral conductors. So 705.28 is going to play a critical role in that conductor sizing. And then you have the overcurrent protection, which is 705.30. You're going to have to provide the proper overcurrent protection as part of 705.30, where you have the 705.30A is your circuit and equipment. B is your overcurrent device rating. C are marking requirements. And then D, suitable for backfeed. So you got to think this, the power flow, which I think I need to demonstrate the power flow. So power flow. I don't really, I don't show the power flow during normal operation on these slides because I should, but I don't. But that disconnect, the power is going to be going from the inverter to the disconnect or through the disconnect during normal operations. But during faults, I have the fault current flowing from line to load. So you have to make sure that the equipment can handle reverse power feed. The other issue that you have with that disconnect is that the load side of those fuses are not barriered. Now, if this is a utility interactive inverter, which, let's take a look at 705.11. 705.11, it doesn't say utility interactive inverters. I need to add that clarity because here's where I'm going. If you look at these line side lugs, I should be able to get a pointer, shouldn't I? Whoop. Laser pointer, there we go. I don't know if you can see this, but this set of lugs here, these lugs are barriered because they're coming from the utility, they're always on. And if I open this disconnect switch, I want to make sure that I barrier off those energized parts. These terminals, the moment I open this disconnect switch, this inverter shuts down. So I don't have these energized. For a utility interactive inverter, I believe in 690, there is a type of inverter that is can operate in parallel with the utility. I think they call it a hybrid. 690 is getting smaller and smaller and smaller. It's amazing. I'd have to look again at that. I don't know. Oh, yummy fudge, but the inverter is still the control device. Yep. Hey, Mr. Electric, I got to scroll down. Perhaps you will have this on a different slide, but it's very common to have the inverter feeding an essential loads subpanel. subpanel. Oh, I'm trying to understand how that subpanel can handle fault conditions. I will. I don't have it on a slide, but I will show, because what I don't show, Yummy Fudge, what I haven't done here, I don't have the connection to the load side of the service disconnect. That's a 705.12. I have to draw that yet. And then what I'll do is I'll show, to your point, a subpanel that has specific loads that has an inverter and supplying power to a subpanel. I can get where that's coming from. And I wonder, so here's the other aspect that I'm not showing, what I sort of am, because I have the in this diagram, let me find it. In this diagram here, I have the energy storage system shown, all tied into the inverter, and the inverter does that management. But I have another system that I answered some questions on. It was in West Virginia, where we had a generator, photovoltaic system, and an energy storage system all on the same structure, and all in the same structure. And then what they did was they made it such that they first powered off the generator, and if they lost the generator, then they went to the energy storage system. And the photovoltaic system was there to power the energy storage system, basically. And any excess, it could supply power to the normal loads whenever there was, utility power, etc. But for the most part, the energy storage system was a backup to a backup. So if the generator, say it was a diesel generator, and the generator ran out of fuel, then you ran off of batteries. And then the solar panels would charge the batteries. But in those cases, I lost the utility, and I have to supply power. So I need a standalone system capability. It is fun. These systems can be complicated, but fun to try to understand. Perhaps you'll have this on a different. So Yummy Fudge, I'll address that maybe for next week. I got it. Inverter switches only for the DC part. Forget my previous question. Sorry, Felix, I didn't see that previous question. Robert Nelson, how to be sure the equipment can handle reverse power feed? Okay. So you go to the manufacturer's instructions. What you will find is I'm just going to do, well, I thought I was going to, but there it is. If you have a circuit breaker and it's marked line and load, you cannot reverse power feed through that. So you've got to follow the rules and find the right, I would say go to the manufacturer's instructions and look for that information. All right. Here's a note from Schneider Electric. Ability of circuit breakers to be reverse fed. Circuit breakers, any circuit breaker that does not have line and load identifying marks may be reverse fed. See the compiled list below. And these are all of their models that breakers that can be backfed and exceptions. So this is an FAQ created by Schneider, but I would say in general, if it's a circuit breaker, make sure it doesn't have line and load. That's going to be your indicator on whether or not you can backfeed. Oh wow, that system. Yeah, Yummy Fudge. So I think you're right. So I know in the past there were inverters that could work in parallel with the utility or in standalone. So if you lose the utility, it won't shut down, and it'll still provide power to the to whatever it is. So you sent me an email, Yummy Fudge. If you send me an email with a good example, I will take a look at that. I'll have to work that into the next meeting. These inverters are getting more and more things they can do. Yeah, I agree with that. So I've seen inverters that can manage the generator, that can manage the energy storage system, that can manage the PV and the wind. They're getting, to your point, they're getting more and more complicated, more and more feature rich. I'll say that. But that just means we need to make sure we apply them correctly, right? So we got to really cross our T's, dot our I's, and all that jazz. So we got to be we have to do our due diligence and make sure that I opened up all of these stupid windows, and I don't know why I did that. So got to make sure that we are applying all of those correctly. And you know what I might do is I might reach out to an inverter manufacturer and maybe have the discussion with that individual on there. All right, Yummy Fudge, you sent it to my Eaton address. Maybe. But I will look for it. And I'll also look at the at my other emails too. So no worries about that. I just have too many email addresses. And with the election, I'm tired of getting emails from. At this point, I just want to tell people I'm not even going to vote because I'm tired of getting your emails. Anyway, Yummy Fudge, I will look at that. We'll do that next week. Next week, I will be driving. Thank you, Yummy Fudge, because I don't see it. Send it to me. I appreciate it. I'm not sure. Hopefully, I'll be able to go live next week. I have to drive up to Upper State New York to do a class on Wednesday, Thursday, and Friday. So I believe I'm leaving Tuesday, but I will see if I can go live. If not, I'll have to record a session. But in any case, I will not miss next Tuesday, one way or t'other. All right, everybody. It is 1:03. We had a good full hour. Great discussion. I appreciate everybody chiming in. Great feedback. I hope I got everybody's notes and chats. So I do appreciate the engagement there. If you are viewing this at a later date and you see any issues with the slide deck, please send me a note. I'm trying to put my graphics together to demonstrate and show the interconnections of systems and whatnot for a formal IAEI educational program that is up to date based on the latest code requirements. So in any case, services are complicated, right? It's getting more and more complicated because we're trying to do more and more in pulling systems together at that point in the power distribution system. Got to be careful of our terminology. Hopefully the terminology review helped. And we have to make sure that once we understand the defined terms, that we apply the code rules appropriately. All right. Thank you, everybody. Good afternoon. And Jody, Wade, thanks for joining in. Jody and Felix Sandoval, Steve Cavaleris, David Englehart, as usual. Thank you. And Laurel and Michael Hofkin, everybody. I appreciate you dialing in. I appreciate the chats. And Willie Snyder, I appreciate you too, buddy. And Scope. Yes, I will do that. I should run for president. Yeah, I'll just start sending you emails, Steve. Oh, my goodness. Thank you, Felix. And everybody, take care. Stay safe. We'll see you next week. Stay safe and please stay healthy. Until next week, take care.